Here, I'm going to give you some tips on how to input the mathematical model we have into ANSYS. And I suggest that as a starting point, you use the project at the end of the 2D steady conduction tutorial in my EDX course. So if you go to the EDX course, Module 1, Section 1.4, 2D conduction, and if you go through all the steps in the tutorial, at the end of it, your ANSYS project will look like that. And now we have a slightly different mathematical model. We have the unsteady version of it. And to turn on this equation in ANSYS, what I'll do is I will drag steady state thermal, or rather transient thermal, into the project page. And this has turned on the 3D version. We'll have to set it to 2D, and I'll get to that in a moment. But I'll say this is 1D unsteady conduction. We'll solve it as 2D, but the problem is really 1D. And for geometry, if I go back to my slide, we need a rectangle of width 1. The height is arbitrary. And in the tutorial, we had a rectangle of width 1. So what I can do is I can just copy the geometry on over here by just dragging it. And now if I right click on geometry and look at properties, it's been set to 2D because this also is a 2D geometry. So with that property set to 2D and transient thermal, ANSYS now has that equation turned on. And we need to give the right values of the material properties. We'll do that a little bit later. And one can go and generate the mesh, and I'll show you what my mesh looks like. So here's a mesh I have. I put in face meshing for uniform mesh, and I put in some edge sizings. And now I have 10 elements along the X direction, and I have one element along the Y direction. And I do one element along the Y direction because I don't expect any variation in this direction. And in the edge sizings, I turned the behavior to hard in both cases. So I'm telling ANSYS, hey, this is a hard setting. Don't override it. By default, it'll be a soft setting that it can override as necessary, which usually you need for complex geometries, as I've talked about elsewhere. And you also get a warning over here saying that some local edge element sizes are larger than the global maximum size. So ANSYS has some, internal sizings that it turns on based on the geometry. And let's just turn that off. For this geometry, we don't need that. So you can go to Mesh, Sizing, and essentially turn off size function by changing this to adaptive. And then if I update the mesh, that warning goes away. Okay, so that's all there is to the meshing. And then if I go to the, complete the mathematical model specification, the mesh, of course, doesn't affect the mathematical model. Let's set the material properties to be 1 so that this equation looks like that. So for that, I need to go to the project page. I will double click on engineering data. I'll create a new material. I can call it whatever. So I'll just call it blah. And I need 3 material properties. I need isotropic thermal conductivity. So I can just drag it onto blah. That's K. I need density. I can double click on it or drag it. I'll double click it. So that's added density. And then I need specific heat. Okay, and all of these are set to 1. And then if I go back to the project and say refresh, all this should look familiar. And I'll say refresh over here too, so that the upstream changes propagate through. And then I can go and select the right material over here, which is actually under surface body. So I can change that to blah, and that set those three constants to be 1. And then what else do we have? We have the initial condition to be set equal to 1, and that you do initial temperature. So that's going to be 1. And then you have the boundary conditions, which I have shown you. I've indicated in my previous video how to do the boundary condition. So you can go ahead and do that. And at the end of it, you should have this mathematical model specified in ANSYS, and you can save the project.